Hello. So we'll start today with hash map. So basically, what is an hash map? I think let me write it. A hash map. Little better. Uh, a hash map is an array of buckets. Uh, each bucket contains nodes, and the nodes have key and value pair. So this is where the data is stored. Uh, when we first declare any hash map, for example, uh, hash map map equals to new hash map. So this makes it a default size of 16 is given to this initial hash map. So the internal structure for hash map is something like this. So whenever we declare, there will be an array. Okay, let's start with 0, 1, 2, 3, 4, and there is 16. Okay, for right now, let's see what this stores. So each of these is a node, and inside each of this node, it contains a linked list. So we'll get back to that why a linked list is required. But let's suppose we do hashmap dot put method and we give it some uh, a key, suppose a and a value 1. So when this is called, what exactly happens is, for now, let's consider that the index is calculated based on the key. So the key is a. So what does a hash map first do is calculates this hash code of this A. So a number is generated. It performs an AND operation uh, based on the size of the table. So this is a table. Uh, so whatever the hash is generated, it does an AND operation on capacity minus 1. So right now it will be 15 as the total size is 16, and based on that index is generated. So I think this index, oh sorry, index is generated here, and using this index For sake of our example, let's consider this index is generated is 1. So HashMap will take this A, this 1, value 1, key A and value 1, and directly insert it here, A1. Then we again uh, do another put operation. That is, let's take put B and 2. So this for this B, the hash which generates using this ampersand and n minus 1, we'll consider it currently the index that is generated is 3 for this. So it will take this B and 2 and add it on this position. Okay, so so far so good. So we'll need let's consider we need to add one more. So index is nothing but hash ampersand n minus 1, capacity minus 1. That is the our index. So we do another put and c and 3. For this index, let's consider that the index that is generated based on the hash and the capacity minus 1 is 1. The hash goes to this position near 1, but it checks that A is already present. Some value is already present in that space. So what it does, it checks for the equals. Now here comes the equals method. It checks the equality between the two uh, elements. But as you can see that C of 3 and A1 are different. So what it does, it checks the next position of this and stores, as there is only one element, stores C and 3 at this position. So this is why linked list is present in each bucket. All of these are buckets. So in each bucket, uh, there is a node of key value pair, and that is a linked list. So it can quickly traverse all of this. So this is the basic structure. Actually, it doesn't just store these value. Basically, it stores the hash, not just key value pair. It stores the hash, then the sorry, then the key, then the value, and the next. Sorry, this is the next I could draw. So this is the next. So next is nothing but this node, the node which contains A will initially will be null, but when this C of 3 will be added, it will contain, it will point to this. So it is a linked list. Okay. So uh, a common topic that is asked is what if we want to add 100 elements in a linked list? Where will they be stored? This is commonly asked in interviews. So first we'll ask if what is the key that are we storing, and most probably in interview they say that employee employee class uh, is the key that is being used as a key, and there are some value. For example, put e1 object and there is some value, suppose HR, something like that. So then we'll ask if we know uh, that if we don't know that there are 100 elements that are going to be put, or 99 or 110, then we can start with saying that initial capacity is 16, but whenever threshold is reached for uh, threshold is reached for the table. So the table is of 16. So threshold is nothing but 0.75 of the total capacity. So it will be at 13. So whenever the 13th element is inserted, the capacity doubles. So from 16, it will go to 32. And same for 32's 75%, it will double to 64. So on and so forth. So it keeps on increasing. So another, uh, okay, I'll get back later. But this is the initial capacity. So let's talk about the contract between equals and hash code. So in our employee class, EMP, there should there is an ID and name, mm, and name. So we'll need to override in this class hash code and equals. These two methods needs to be overridden in the employee class. So the contract. So what is the contract? That has, if two objects, suppose E1 and E2, both of these uh, hash code is equal, both of these objects hash code is equal, then the equals should also give that they are same. But the reverse is not true, that the equals uh, to uh, E1 and E2s If they both are same, then the hash code should be same. This is the basic contract. So, so uh, we need to override hash code and equals. But if we don't do the overriding of equals and hash code, the default, uh, by default, it will use the object class equals and hash code. So, as you know, object class is the parent of all classes in Java. So it will by default use object class hash code and equals method. So why is this problematic? Because it compares, it uses the memory address to create a hash for identity hash. So we don't want that. And also the equals uh, use is the equality operator. So the equality operator, as you know, so in string, we gather that this equality operator compares the memory address or the string pool. That, but that is not currently required. So equality compares the memory of the two objects. Suppose E1 and E2. So even if they are same, the contents are the same. As the memory address is different, this will give false. So the contract between hash code and equals breaks. Yeah. So, but we are good developers. So we'll implement the hash code and the equals method. So for ID, we can in equals. So another thing. Uh, so we are generating hash code, but hash code of what? Of ID or name or both? That needs to be decided. So the answer for this is if we are uh, if the employee ID this is unique, then we can generate hash code based on this. But the catch is that the equals method should also compare just the ID and not the name. But if name is being compared in the equals method, then we'll need to generate hash code using both of the fields ID and name. This is the basic idea. So hashing is quite simple. We just return objects dot hash in ID and name in the hash code method of employee, the one which we are overriding. And in equals, ID can be directly checked using the equality operator, uh, and the name can be used using the objects dot equals, where we check the uh, content or logical equality, not just to compare the memory addresses if they are same or not. So this is the uh, basic rules. And as I said, equals and hash code must be consistent. A dot equals B is true, then A dot hash code should be equal to B dot hash code. But the reverse uh, is not compulsory. If A dot hash code is equal to B dot hash code, then A equals B is not compulsory. But A equals B should be equal to A hash code equal to B hash code. So this is the basic premise. Uh, let's code a few. Uh, okay, so let's start with the basic HashMap. Key is a string. We are using string because strings are immutable. Map equals to new hash map. So this map dot put, let's put in some element abc 1k. I just want. Okay, so running us gives us this map map dot df2. Okay. uh, let's create an employee class. Java class employee and integer id string name and at the rate override. Public, uh, let's toString start. Will toString is also used, but let's start with integer and hash code. Here we return the objects dot hash of id and name. Excuse me. And boolean. There is our equality. So this line, mm, first let's check if this is equal to 0. this is equal to O. If it is true, then return true. And uh, okay. And if is not equal O, O instance of employee. So here we are checking if O object is the instance of employee. So if it is not, we directly return false. If but if that is not the case, then we first cast the object as it is an object. We need to cast it to the employee, and we this line also makes sure that there are no typecasting errors when we do this. And sorry, and here we check if objects, so ID is equal to employee ID. So this is the object. We casted it here into employee object, and this is the employee ID, the object which is passed. It checks if it is equal to the ID field, and name is equal to object that is passed, that's name. So this is how we override, uh, this is not required, the override annotation, but still. So this is how we override the hash code and the equals method. Okay, I think this is it. Uh, let's create a object map to employee. So in map dot, sorry, first we'll need an employee object. So let's start with an employee e and assign e dot id. You know what? Let's create a constructor. Let's create a constructor, basic constructor, employee, where id and name are passed, and we assign this object with the id that is passed and this name with the name that is passed. So we can quickly add the id that is 101 and the name that is abc, string k, with this e1 and employee 2 E2 102 DEF. Okay. In map 2, we put a, I think I'll add dev. Map 2, put, I'll keep this as QA. Corporate system dot println. Mm, let's see. So this should give us 101 and ABC. Oh, sorry. As these are an objects, we need to do dot get my pad. Here we got the dev. Okay, okay. So this is it. Uh, this is how we override both of these methods. I think. Okay. Thank you very much.